And these are the notes on geometric mean. Okay, so geometric mean is an average. Okay, like mean, median, and mode. Mean, median, and mode are types of averages. It's going to indicate the central tendency of a set of numbers. The geometric mean is calculated by taking the nth root of the product of the data set. So let's start off by, through all middle school and high school, if you're taught to find the mean, you're really taught to find the arithmetic mean. Okay, and how you would do that is you would add the two numbers together and divide by however many numbers there are. In this case, there's two numbers. So we would get 34 over 2, which is 17. So if you strung out a number line, wanted to find the average here, you would get 17 because they would both be 8 units away from 17. Geometric mean, though, okay, it's really more got to do with proportions. Okay, so let's find the geometric mean, then we can talk about it. It's telling us that it's going to be calculated by taking the nth root of the product of the data set. So here we have two numbers, so n is going to equal 2. The product of the data set, so it's the second root. So the second root is a square root, so it's just square root. So we don't need to write the 2 of the product. So product means the result of multiplying. So 25 times 9 should give us 225, and the square root of 225 is 15. So the geometric mean is 15. So what that's telling us here, if we have a sequence, so 9, 15, 25, it's going to be the same jump from 9 to 15 as it is from 15 to 25. So to get from 9 to 15, you need to multiply by 5/3. So here we need to multiply by 5/3. Okay, to get from 15 to 25, we're going to need to multiply by 5/3 as well. Okay. So it's the number. Right, it's going to be proportional. If you had a proportion 9 over 15, it's going to equal 15 over 25. For the next one here, we have 3 numbers, so n is going to equal 3. So it's going to be the third root or the cubed root of the product of the numbers. So that's 4 times 10 times 25. That's going to be 40 times 25, which is 1,000. And the cubed root of 1,000 is 10. Okay, so your geometric mean here is going to be 10. Let's go to the next slide. So this next slide is going to demonstrate why you want to use geometric mean. Okay. So the example here is that you want to buy a new camera and you want to figure out which camera you want to buy based on its value. Okay, and there's two qualities you're looking at. You're looking at the zoom of the camera, and you're looking at the how well it's rated, how good reviews it gets. So the first camera has a zoom of 200 and gets, let's say, 8 out of 10 in its reviews on average. The other has a zoom of 250 and gets 6 out of 10 on its reviews. Okay, so if you did this the traditional way with our arithmetic mean, we would add the two numbers and divide by 2. So for the first camera, we would get an average rating of 104. And for the second camera, we get an average rating of 128. But the problem is it's not going to tell us a lot of information. So these two types of numbers, the 200 and the 250, greatly outweigh the 8 and the 6. Okay, so the arithmetic mean doesn't really help us because it completely is biased towards the zoom. Right? So the second one's a lot bigger in value here, 128 over 104. But the reason for that is because we put the zoom, it emphasizes the zoom much more than it does the reviews because the reviews are much smaller numbers. It doesn't really distinguish between the range of numbers for each category. So 200 and 250 greatly outweigh 8 and 6. So we need, instead of using the arithmetic mean, we can use the geometric mean. So to find the geometric mean, we're going to have, again, square root, because there's two values, 200 and 8. So we're going to have the square root of 200 times 8. That's going to be 1,600, so it's going to be 40. Square root of 1,600 is 40. The other one, again, two numbers, 250 and 6. So it's going to be square root, because there's two numbers, 250 times 6. And that is 1,500. Which is 38.7. Okay. So if you're using the arithmetic mean, you would want to have picked the second camera. But again, there's a problem with that because it's emphasizing the zoom more than it is the reviews. Because the numbers for the zooms are much bigger than the numbers for the reviews. So if we do the arithmetic mean, it kind of makes things more proportional. And the value and the weight of the zoom and the reviews are equal. They're more proportional to each other. Okay. So if we use the geometric mean, we can see we would want to use camera 1 has a greater value to us. Okay. Right. And if we want to see that as a proportion, right, 8 to 40, it's going to equal 40 to 200. Right. So you need to multiply 8 by 5 to get 40, and then you need to divide 200 by 5 to get 40. So it's picking a value that is between these two numbers that kind of puts equal weight on those two numbers. It's 5 times bigger than the small one, 5 times less than the large one. It balances out the small and large nature by finding a number that's in the middle. It's not the arithmetic mean, but it's in the middle such that it's going to be proportional. It's going to be the same distance or magnitude away from the 8 and the 200. Here, again, we would have 6 over 38.7 and 38.7 over 250. So 38.7 is the number we would balance out. The magnitude, whatever you got to multiply by. So let me see, 38.7 divided by 6. So you got to multiply by 6.45 to get 38.7. And then to go from 250, you're going to have to divide by 6.45. So again, the 38.7 represents a number that's proportional. Okay, the same magnitude away. The same magnitude more than 6 is it is less than 250. Okay, so it gives us a number to compare, right? This gives us a number to compare. Okay, we can compare two different sets of values that are very different from each other. Okay. So let's go on to the triangles. So to solve a lot of these geometric mean problems, we're going to use triangles. We're going to use similar triangles. So we're going to start off with a right triangle. We're going to draw an altitude. Okay. So the altitude is kind of like the height. It goes from the vertex of the right triangle to the hypotenuse, and it's going to bisect. It's going to be perpendicular to the hypotenuse. Okay, now if we look at it, we have three triangles. We have a right triangle here, We have a right triangle here, and then we have the big right triangle. So we have 3 right triangles. The other thing we know about these triangles is that they're similar. We know they're similar. Well, one, they all have right angles. Okay, and all right angles are congruent. So if we can use angle, if we find another pair of angles, and we can find another pair of angles. So these 2 angles add up to 90. They're complementary. This is a right angle, so these 2 add up to 90. These 2 are also going to add up to 90. This right here is a right triangle. So, well, it doesn't matter. It's a triangle, so the angle measures all that to 180. So 180 minus 90 is 90. So these 2 angles are going to add up to 90. So these 2 angles are complementary. So these 2 are complementary, and these 2 are complementary. So since these 2 are both complementary to the same angle, we know that those 2 angles are going to have to be congruent. And we can repeat the process for this one and this one. Since they're both going to be complementary to this angle, these 2 are also going to be congruent. So we have 3 triangles, 3 right triangles that are all going to be similar. Okay, and if they're similar, we know their sides are proportional. Okay. So let's see. Next thing we want to do is we want to draw all of them out. So first one I'm going to draw is the blue one here. Okay, the blue one is this small one on the right. Well, never mind. Let's label it first. Okay. So let's call this A, let's call this B, and call this C, call this D, and okay. Now let's draw our 3 triangles out. We're going to rotate them, flip them, so they're all in the same direction, same orientation. So I'm drawing the blue one first. So we're going to leave that one the same and keep it as our standard. Hypotenuse is C, base is E, height is B. Okay, then we can draw the other small one on the left. But let's rotate it. So let's rotate it about 90 degrees. So it's the same orientation as the other one. D is going to be on the bottom. D is going to be over here. A is the hypotenuse. And then finally, our red one, our big one. The big triangle here. And we got to flip this one and then rotate it a little bit. It's going to be C and A are the 2 legs. Okay, and the hypotenuse then is D plus E. This whole thing is the hypotenuse, so it's going to be D plus E. So there's the 3 triangles drawn, the same orientation. We know they're similar triangles. Right? If we wanted to put these in, we could. So they're similar triangles. Right? So using this, there's going to be 3 numbers that represent geometric means. There's going to be the 2 legs of the large triangle and then the altitude. Okay, so we're going to look at each of those. Right, this is a leg. Right, we're looking at the big triangle. Okay, so this is a leg. This is a leg. And B is an altitude. And then D plus E is the hypotenuse of the big one. Okay, so if we want to look at B is part of 2 triangles. B is part of the 2 small triangles, the 2 inside triangles. Okay, so that's these 2. B is part of both of them. Since they're similar triangles, we can set up a proportion. Okay, so B is going to correspond with D. And then E is going to correspond with B. It's not super relevant right now to you if you haven't seen any problems. But by being able to put B in two spots here, we have less variables, right? So it's going to help us if we only have an altitude. If they only gave us B, D, and E, this is the only way we can solve the problem. Okay. So the rule is, if we're finding the geometric mean of B, or for B, really it's the geometric mean of D and E. B is going to be the geometric mean of D and E. So our rule for it is, if we're using the altitude, so again, altitude, and then we have two legs here that are going to be geometric means. These are the three sides that are in two triangles. D and E are only in one triangle each. D plus E is only part of one triangle. So A is part of two triangles, is part of the big one and this small one. B is part of the two small ones, and C is part of the big one and the small one on the right. Okay, so A, B, and C. B is the altitude. So if you're using altitude, you can draw the three triangles out if you want to. Okay, but that's pretty tedious. Okay, so we can follow the simple rules here. So if we're using an altitude, the steps we're going to take is we're going to use both pieces of the hypotenuse. Okay, D and E. So the hypotenuse of the big triangle. So we're going to use both pieces of the hypotenuse. Again, this probably will make more sense once we actually start solving problems. Okay, if we look at A is in two triangles. It's in the small purple one here. It's the hypotenuse of the small one. Okay, it's also one of the legs of the large one. So we know A is going to correspond with D. And then we know D plus E is going to correspond with A. D plus E is going to correspond with A. Okay. So again, we've used A twice now, so we're eliminating a fourth variable. Limiting it to three variables or three spots. So our rule here, we're using D and D plus E. So if we use a leg, so A is a leg, so if we're using a leg, altitude, leg, if we're using a leg, okay, our rules are going to be, first we're going to use the closest piece or adjacent piece. Let's say closest. Closest piece of the hypotenuse. Okay, and then we're going to use the hypotenuse. Okay, so here the hypotenuse is D plus E, and the closest side is D. D is the closest. Okay, and then D plus E is the hypotenuse. Okay, again, altitude, we're using two pieces of the hypotenuse, D and E. If it's a leg, we're using the closest, and then we're using the hypotenuse. And the last one, C is a leg, so it's going to be C over. The closest one is E. Closest piece of the hypotenuse is E. Then we're using the whole hypotenuse, so that's D plus E over C. And again, we don't need to, if we're struggling with that, we just then have to draw out the three triangles. Okay, C corresponds with E. D plus E corresponds with C. But let's get to some practice problems, if we will. Okay. Or let's look at this table first. Okay, so this, again, altitude, leg. So if it's an altitude, we're using the two pieces of the hypotenuse. So the two pieces of the hypotenuse are H1 how do we write this? H1 and H2. So H1 over X, X over H2. You could have done X over H1 equals H2 over X. Okay, same thing. Here's a leg. So you want the closest one. So H1, and then we want to use the whole thing. So H1 is the closest, and then we're using H1 plus H2. Here's a leg. Closest is H2. And then we're using the whole thing. So if it's altitude, you're using the two pieces. If it's a leg, you're using the closest piece and then the whole piece. If it's a leg, you're using the closest piece and then the whole piece. So H2 and the whole thing. So let's do examples. See how we're doing. Okay. We want to find D first. So D is an altitude. So if we're using an altitude, we're using the two pieces of the hypotenuse. The two pieces of the hypotenuse are going to be 4 and 9. So we can do D over 4 equals 9 over D. Or we could do D over 9 equals 4 over D. Or we could do 9 over D equals D over 4. Any of those would work. We can't see it. We got to draw the triangles out. So let's draw the triangles out. So D is part of this small triangle, which I'm going to rotate, just like we did before. So it's going to be D and 4. Okay, and then let's draw out the other triangle. Okay, so let's draw it over here. Okay, so it's going to be 9 and D. So D is going to correspond to 4, and 9 is going to correspond to D. D to 4, 9 to D. D to 4, 9 to D. To solve this proportion, we have to cross multiply. D times D is D squared. Okay, 4 times 9 is, well, let's leave it as 4 times 9. If we remember back to 3 slides ago when we talked about the geometric mean and we said find the geometric mean between 9 and 4 and 9. Okay, we did that by doing the square root of the product of those two numbers. The product of those two numbers is 36. So we would have gotten 6. Here, same thing. I mean, how do we solve for D? It's a square, so we got to take the square root of both sides. So we get D equals the square root of 36, which is 6. Okay, so you can write out your proportions. You can do it by using our rule. So if you're using D, it's an altitude, so we got to use 4 and 9. Okay, so D over 4, 9 over D. Or you can recognize that D is the geometric mean between 4 and 9. And if you know 4 and 9 are the two numbers, you can just take the square root of their product. So this way or this way. D, let's put D equals. D equals. D equals. And this makes sense because, again, if you have an order, 4, 6, 9, you need to multiply by 3 halves to get there, and then you need to multiply by 3 halves again. Okay, or you can think of it as 4 over 6 is going to equal 6 over 9. Okay, it's proportional. It's the same magnitude away from 4 as it is below 9. The same magnitude in terms of what do you have to multiply to get 6? You then have to divide by 9 by to get 6. Let's do the next one. So, well, D we know is 6. Okay, to find E, well, one thing let's fill in first. The hypotenuse here is 13. 4 plus 9 is 13. So the whole thing there is 13. Let's look at E though. E is that a leg or an altitude? It's a leg. Since it's a leg, we want to use, for the rule, we want to use the closest piece of the hypotenuse and then the total hypotenuse. So the closest piece of the hypotenuse is 9. So let's do E over 9. Then we want to use the whole hypotenuse, which is 4 plus 9, or 13, over e. We can cross multiply. E squared equals 9 times 13, which is 117. Square root. So we're going to get e equals square root of 117 should be 10 point something. 10.8. Okay, 10.8. Okay, again, the other way we could do it, we know that E is the geometric mean of 9 and 13. It's the geometric mean of the closest piece and the long piece here, the whole hypotenuse. So we could say, what's the geometric mean of 9 and 13? Well, it's going to be E equals square root of 9 times 13, which is 117, which is 10.8. Okay, and if we can't do it that way, we can also, again, draw out the triangle. So if we draw out the big triangle here, D plus E, so this was 13. This was E. This would be F. Okay. This would be E. This would be F. Okay, so if we set up our proportion, E would correspond with 9, 13 corresponded with E. So that's how we got our proportion if we didn't know the rule. Again, the rule is the closest piece of the hypotenuse to the total hypotenuse. That's where we're getting 9 and 13 from. Okay, and then the last one here, don't have a lot of room. Let's do it up here. Okay, so we want to use F. So F is a leg. So it's going to be F over the closest piece of the hypotenuse, which is 4. And the total hypotenuse is 13. Or we could have used the two triangles here. So F is to 4 as 13 is to F. So F corresponds with 4, 13 corresponds with F. So F over 4 equals 13 over F. We can cross multiply. F squared equals 52. Take the square root of both sides. F is going to be the square root of 52, which is 7.2. Okay, and again, if you knew F was the geometric mean between 4 and their whole thing, 13, okay, you could just do F equals the square root of 4 times 13, which is going to give us 7.2. Okay. Right. So if you're using the altitude, you're using the two pieces of the hypotenuse, the 4 and the 9. Okay. If you're using a leg, you're using the first piece that's closest to the leg, and then you're using the whole thing. So 4 and the whole thing is 13. Here again, E is a leg, so closest piece is 9, whole thing is 13. That's the geometric mean. And let's do one more example. Okay. One more example. All right. Start with 12. So again, these are the three parts that are going to all be part of two separate triangles. H is part of the big triangle and this small one. 12 is part of the two small ones. And J is part of the small one and the big one. If you feel the need to redraw all the triangles so they orient to each other, go ahead and do so. That's fine. Okay, but we can also try and use the rule. So let's start with the 12 because that's not, again, we want to eliminate variables. If we did H, we'd have two variables. If we did J, we'd have two variables. So let's use 12 because then we're limited to one variable. The only variable is going to be the G. So 12 is in two different triangles. It's an altitude, not a leg. It's an altitude. So if we're using an altitude, we're using the two pieces of the hypotenuse. This is our big triangle here. So we're using the two pieces of the hypotenuse, the 5 and the g. So let's start with 12. So 12 over 5 is going to equal g over 12. Again, g and 5 are part of one triangle each. They're not part of two triangles. 12 is part of two triangles. It's part of this triangle and this one. Okay. So it's getting used twice. If you got to redraw the triangles, that's fine. Cross multiply, 12 and 12 is 144. 5 and g is 5g. Divide by 5, divide by 5. That should be 13 something, right? I mean, 28 something. 144 divided by 5. 28.8. Yeah, 0.8, right? 28.8. Okay. We now know that g is 28.8. We can find the whole hypotenuse. Okay, so the whole hypotenuse is going to be 28.8 plus 5, which is 33.8. So now we can look at h. H is the leg. So again, our three geometric means are these three. Okay, this was the altitude. The other two are legs. So let's do h. So if we're using a leg, we want to pick the closest piece of the hypotenuse. The closest piece there is 28.8, adjacent to the leg. Then we want to use the hypotenuse itself. The whole hypotenuse there is 33.8. And then we're dividing by h. Cross multiply. That's h squared. 28.8 times 33.8 is 973.44. Take the square root of that answer, 31.2. Square root to go to the square, 31.2. Okay, and then our last leg here is J. J is a leg. We want to use the closest piece of the hypotenuse, that's 5. Okay, and then we want to use the whole hypotenuse, which is 33.8. Divide by J, we can cross multiply. J squared is going to be 5 times 33.8. Okay, which is exactly 169. Square root of both sides. J is going to be equal to 13. Should have known that because that was a 5, 12, 13 triangle, but that's all right. Okay, so if you're using altitude, you take the two pieces. If you're a leg, you take the closest piece and then the whole thing. All right, that's it for the notes. On to the practice.